In this video, I'll be working through the question you see on the screen here from the summer 2025 Cambridge A-Level Maths paper 1-1. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts as much as you need to. If you are looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 2, they talk about a curve that goes through this point here. This is not the equation of that curve. In fact, later they ask us to find it. This is the derivative of that curve. So that's what they give us. They give us a point on the curve. Let's just draw a random curve. It really doesn't matter what it looks like. Here's a curve, and what they're telling us is, here's the derivative of it, and it does have this point. What they're asking us to do then is to find the gradient of the normal of the curve at this point. So put that another way. So there's some point, let's say it's here. It has a gradient and it has a normal. A normal is just perpendicular to the gradient. If you find the gradient, you find the normal. So that's not too difficult. There's only 2 marks for this question. So there's not really, it's not trying to be difficult. The next thing to remember, and it's very important to remember, the gradient is the derivative. The derivative is the gradient. So if you're looking for the gradient of the tangent, sorry, I should say the gradient of the tangent, let's call that t. T is equal dy dx. The gradient of the tangent is this. At a certain point, when x is equal something, it'll give us every possible answer it will. At the point here, this is when x is equal to 4. So when x is equal to 4, we can find the gradient. We just put it in. This is all equal to 4. We just put x in, 4 in for x. 4 times 2 times 4 minus 5 to the power of 3 minus 9, and that's 4 to the power of a half. That's the square root of 4. Just clean all that up. Let's see, we have 2 times 4 is 8. 8 minus 5 is 3. 3 to the power of 3 is 27. 4 times 27 is 108. So obviously, do that slowly, carefully, triple check all that. And the square root of 4 is 2. 2 times 9 is 18. So the gradient of the tangent is 90. What is the gradient of the normal? Well, that's it's easy to do. We turn it upside down and change the sign. So the answer they're looking for, the normal, is minus 1 over 90. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Now for part B, I'm going to guess a lot of students made a big mistake even before starting this question. Part B and part A were not related at all. In part B, they asked us to find the equation of the entire curve, not of the normal or of the tangent. I'm guessing some students thought that. How do we get the equation of a curve? This is the derivative of the curve. How do we get back to the curve itself? Differentiation got us here. What's the opposite of differentiation? Integration. If we integrate this, we get back to the curve. Basically, I want to get back to y equals, and y is equal to the integral of the derivative with respect to x. Basically, it's opposite. It destroys the derivative. So what we want to do here is integrate all of this. So let me write that out. The integral of 4 times 2x minus 5 to the power of 3 minus 9, 9x to the power of a half. And all of this is with respect to dx. This is what they're asking us to do. Integration is not too bad in some respects. It can we can do terms separately. So we have 2 terms here. We can do the first one, then the second one. Second one's not actually too bad. So let me first of all split this up. Also the 4 here That's a constant, it can come outside. 4 times 2x minus 5 to the power of 3 with respect to x. Take away, we'll leave the 9 outside, the integral of x to the power of a half with respect to x. This again, this isn't too difficult at all. This is the one we'll concentrate on. It's not too difficult, a lot of students do it quite quickly. And you know what, let me do it slowly. Let me use substitution. I'm going to solve this part of the question, and then I'll show you how you might do it quickly if you want to. Okay, let's continue this part over here. I will use substitution. I'm going to substitute this bracket for u, or u for this bracket. U is equal to 2x minus 5. When you do substitution in integration, we need to differentiate this. Du dx is equal to. Now it's very important when the derivative is something so simple, just a scalar, just a constant, we're able to do the shortcut I'll show you in a moment. Rearrange this so x is on its own and 2 is underneath. We get dx is equal 1 over 2 du. That allows me to, instead of writing this, to instead write 4 times the integral of u cubed, and instead of dx, so I've replaced this with u, I'm replacing dx with this 1 over 2 du, and of course the 1 over 2 doesn't have to stay there, it can come out front. Let me continue this whole thing on, do it all in one go. Minus 9, let's integrate this while we're here. X, we add 1 to this power, that becomes 3 over 2. And then we divide by 3 over 2. Dividing by 3 over 2 is the same as multiplying by 2 over 3. 3 goes in 3 times. And that's it. Let's integrate this. We'll continue up here. This becomes 4 divided by 2 becomes 2. The integral of u cubed is u to the power 4 divided by 4. And we'll write this in here. 3 times 2 is 6x 3 over 2. But remember, we made that up. Let's replace it back. Let's put it back to what it originally was. 2 and 4 go in half. That becomes 2x minus 5 to the power of 4 minus 6x 3 over 2. Now I've left something out there. I probably first should have put it in here. When you integrate and they don't give you any limits, we get a constant. So this, a constant should have appeared here. Another constant should have appeared here. 2 constants add together, we get a constant. So I'll just add it all in at the end here. Just be careful, probably shouldn't do that. You probably should add, let me add in C1 here, some small constant. C2 here, plus C1 here. 2 constants add together to get a constant. This is y equals all of this, y equals all of this. You're nearly finished. You give you 4 marks. They'd probably give you 3 marks for this. Maybe not though, because you're missing one thing. An equation of a curve should have a y, should have an x, but it shouldn't have this c thing, this random constant. I want to know what that c is. We have everything we need to in this point. This point tells me at some point in the world, x is equal to 4 and y is equal to minus 11 over 2. So if we put that in, the only thing left will be c. We can find what c is. C doesn't change. If I find it in this one small part of the world, I find it everywhere. So let's write this out again. Instead of y, I got minus 11 over 2 equals, let's see, put 4 in. We already did that. 2 times 4 is 8. 8 minus 5 is 3. So we get, let's see, a half. We get 3 to the power of 4. Minus 6. This is a 4 in here again. 4 to the power of 3 over 2. That's the same as getting the square root of 4. That's what this divide by 2 would do. Square root of 4 is 2. 2 to the power of 3 is 8. Double check that on a calculator. 4 to the power of 3 over 2 should get 8 plus c. Let's clean this up a bit and multiply everything by 2. So on the left side we get 11. I'll multiply by 2 basically. Multiply this by 2, that disappears. We're just left with 3 to the power of 4. That's 3 by 3 by 3, which is 9 by 9, which is 81. Again, I multiplied, so 6 by 8 is, you can do all this in a calculator. 6 by 8 is 48, but I multiplied everything by 2, so I get minus 96 plus 2c. I multiplied everything by 2. Rearrange that, we get 2c is equal, let's see, we get minus 15 from these two, move that over, we get plus 15, take away 11 is 4, c is equal to 2. I ran out of room here. I might lose a mark for this. This, I don't know. They might give you full marks for leaving this as your answer. It's right, but what they really want to see is this line here once more. They want you to write this line out once more, but instead of having a C here, they want you to put 2. So don't lose that mark. So I've no real place to put it. I guess I could squeeze it down here in the bottom, but yeah, you can see what I mean. Write this again. Everything you see here, except for C, put in a 2. Okay, that's it for question 2. If you have any follow-up questions or you see any mistake I made, just let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.